Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to discuss about robot control system and decision making system. So in this PowerPoint presentation, we are going to discuss about the soft real-time control and OODA loop. First we see the introduction. What is the robot control system? So a robot control system is the central mechanism that governs how a robot senses, processes and acts within its environment. It takes input from various sensors, processes that data and sends commands to the actuators and motors to perform desired task. So the effectiveness of control system determines how reliably and adaptively a robot can operate, particularly in dynamic or unpredictable environments. Next, we see the importance of consistency, autonomy and feedback. So the consistency, it ensures that the robot perform action reliably and predictably. Without consistent control, your robot actions could vary significantly even under the same condition. So next one is autonomy. So autonomy refers to the robot's ability to make decision and act without human intervention. So an autonomous system can interpret sensor data, plan actions and execute tasks independently. Next one is feedback. So the feedback is essential for adaptive behavior. It allows the robot to measure the results of its actions and adjust accordingly. So it forming a closed loop system. Feedback enhances and robustness, especially when dealing with environmental disturbance and uncertainties tool used. So what we are using tools, there are soft real-time control and OODA control. So the soft real control, time control, it's referred to a control approach where timing constraints are important but not absolutely critical. So soft real-time control is sufficient for most robotic applications where occasional delays are tolerable. It enables flexibility while still ensuring that responses happen within an acceptance time window. So OODA. So OODA means Observe, Orient, Decide, Act loop is a decision-making framework initially developed for military strategy, but it's highly relevant for robotics. Next, we see the soft real-time control. We will see the example. So in this diagram represent architecture of a control system for a mobile robot or autonomous system. It illustrates the flow of data and control signals from sensors and video input to the actuator, that is a motor and servos via decision making and communication modules. So the process begins with sensor and a USB camera collecting data from the environment. So the camera video is fed into the process video module where image data is analyzed, like for object detection or path tracking. So simultaneously, data from other sensors is gathered by the read sensors block, which collects information such as distance, temperature or orientation, like that. So this sensors data along with processed video information is sent to the make decision module. This is where the robot determines how to respond based on the input such as moving forward, turning or response to or stopping. It may be influenced by commands received by over a Wi-Fi network, which allows for remote control or monitoring. Telemetry data for the robot can be sent back to the network to a remote system for oversights for logging. Next, we see the why timing matters. So in robotics and control system, timing consistency is crucial for stable and accurate behavior. So let's break down why timing matters, what goes wrong when it's inconsistent, and how to fix it using tools like a PID controller. First, we see the why timing matters. So when a robot control loop run at irregular intervals, the calculation for the motion and feedback become unreliable. Think of it trying to see car with unpredictable delays between turning the wheel and the car responding dangerous and imprecise. So next we see the inconsistent loop timing. It's a bad control. So its loop timing fluctuation, path planning becomes inaccurate, commands may be too early or too late. So here we have the example of PID controller. So the PID controller that means proportional integral derivative calculates the error between a desired set point and the actual values, desired set points and actual value, then adjust the system to minimize the error. But here the catch, if the time between updates is consistent, the integral and derivatives part of PID become unreliable because they depends on accurate timing. So here we are using the that formula. Next we see the OODA loop. So OODA means which stand for observe, orient, decide, act. So observe, that means it's a collect sensor data. So decision making framework that provides the foundation for intelligent and adaptive robot behavior. Originally developed for combat strategy, it maps perfectly on robotic system that requires autonomy and fast decision cycle. So first we see the observe. So collect sensor data. In this phase, the robot uses sensors. For example, cameras, LiDAR, ultrasonic IMUs to gather real-time information about its environment. This includes location, obstacles, moving targets, and environment condition. So here the example, a robot vacuum observe obstacle using infrared sensors. Next we see the orient. It means analyze and interpret data. So now robot process the sensor data to build a meaningful internal model of the world. So it may apply sensor fusion filtering. For example, Kalman filters and pattern recognition. It aligns the data with the prior knowledge, objective and context. So next one is a decide. It determines the best action. So based on their interpreted data and current goal, the robot select the optimal actions. This can involve path planning algorithm. So here we see one flow chart. So it illustrates the decision making process used in robotic navigations and avoidance. First we see environment, then it sees the sensor reading. If the goal is reachable, it will go to the stop, otherwise it will go to the it's not reachable, it's detect any obstacles. Then if it not detect any obstacles, it will go to the navigate towards the goal. Otherwise if it detect the obstacle, it moving to the obstacle. And so how to avoid the obstacle? Then if it is a dynamic obstacle avoidance model we are using. So after it will be reach the goal. So next one is act, execute, moment or response. So we come to the end of the section. We discussed about the soft real-time control ensures reliability and OODA loop enables autonomy. I hope you enjoy this section. Thank you.